From differentiation by first principle, a general rule for differentiating a function in the form ax to the power n emerges, where both a and n are constants of any value. That if y is equal to ax to the power n, then its derivative dy dx is given as a n x to the power n minus 1. Let's look at this under the lens of a real function. That is, if y is equal to 5x to the power 3, its derivative, that is dy over dx, would be given as 5 in this case is a, 5 times n in this case is 3 times 3x raised to the power n, which is 3n minus 1, which is equal to 5 times 3 is 15, x raised to the power 3 minus 1, which is 2. And that's the answer to this example. Also, since y is a function of x, as you can see here, we can say y is equal to f of x. That is, this whole expression could be written as this if f of x is equal to ax to the power n, then f prime of x is anx to the power n minus 1. It's exactly the same thing, just that this is in functional notation. They are exactly the same thing. So if you see a problem in either form, do not be daunted. Now let's take a look at some problems. Y is equal to 5 square root of x. The first thing we need to do when we are differentiating by the general rule is to confirm that the function we're differentiating is in the general form, that is y is equal to ax to the power n. And in this case, it isn't. Therefore, we need to apply the laws of indices to fix that problem. Recall that the square root of any value from the laws of indices is that value raised to the power 1 over 2. That is, the square root of x is also equal to x to the power 1 over 2. That is, this function could be written as y is equal to 5 times x to the power 1 over 2. In this case, the general rule for differentiating a function can therefore be applied. That is, dy over dx is equal to anx to the power n minus 1, which in this case, dy over dx is equal to 5 is a, 5 times n in this case is 1 over 2, x raised to the power n again, which is 1 over 2 minus 1, which is equal to 5 times 1 over 2 is 5 over 2, x raised to the power negative 1 over 2. Also recall from indices that x to the negative 1 over 2 is equal to 1 over x to the 1 over 2. That is, this solution here could be written as 5 over 2 times 1 over x to the 1 over 2. And from here, we know that x to the 1 over 2 is the same thing as square root of x. That is, this could also be written as 5 over 2 times 1 over square root of x, which is equal to 5 over 2 square root of x. And that's the final answer to this problem. This problem might seem a little bit more difficult, but trust me, it isn't. It's just a combination of about 3 different questions on the general rule. That said, let's divide it into 3 parts. That this is part 1, this is part 2, and this is part 3. We know that when we differentiate a constant, which 2 is, it becomes 0. Let's differentiate each part uniquely. For the first part, that is 7 over x to the 3. The first thing we always need to do when we are differentiating by general rule is to confirm if the question is in the form y is equal to ax to the power n, which in this case it isn't. Therefore, we would need to apply the laws of indices to fix that problem. We have y is equal to 7 over x to the 3. Recall from indices that 1 over x raised to the power 3 could also be written as x to the negative 3. That is, this problem could also be written as 7x to the negative 3. In this case, the general rule could be applied. That is, dy over dx would be equal to anx to the power n minus 1. That is, dy over dx for our problem is a in this case is 7. 7 times n in this case is negative 3 times negative 3. X raised to the power n minus 1, which is negative 3 minus 1, which is equal to 7 times negative 3 is negative 21. X raised to the power negative 3 minus 1, which is negative 4. And that's the answer to this problem. To the next part, we have 1 over square root of x to the 5. Applying the laws of indices, this could also be written as 1 over x to the 5 over 2, which is equal to x to the negative 5 over 2. And this is in the form y is equal to ax to the power n. Therefore, the general rule could be applied. That is, dy over dx is equal to anx raised to the power n minus 1. dy over dx for this problem will therefore be a in this case is 1. That is 1 times n in this case is negative 5 over 2. Negative 5 over 2 x raised to the power negative raised to the power n minus 1, which is negative 5 over 2 minus 1, which is equal to negative 5 over 2 x raised to the power negative 5 over 2 minus 1 is negative 7 over 2. Negative 7 over 2. And for part 3, we've said that 2, when differentiated, would be 0 since it is a constant. Now, putting all parts together, that is, part 1, 2, and 3, which are negative 21x to the negative 4 negative 5 over 2 x to the negative 7 over 2 and 0 respectively. That is negative 21 x raised to the power negative 4 minus 5 over 2 x to the negative 7 over 2 plus 0, which when rewritten nicely is negative 21 over x raised to the power 4 plus 5 over 2 x to the 7 over 2 plus 0, which is equal to negative 21 over x raised to the power 4 plus 5 over 2 x raised to the power 7 over 2, which when written very nicely gives 5 over 2 x raised to the power 7 over 2 minus 21 over x raised to the power 4. And that's the answer to this problem. By expressing it in the form of the function given, that would be 5 over 2 square root of x raised to the power 7 minus 21 over x raised to the power 4. And that's it for this problem. For the final problem, we can see that y is not in the form a t to the power n. T because the variable in this case is t. And y is not in this form because of this constant that is being subtracted from t. So what we could do is to FOIL to simplify the problem. That is 5 into t minus 2 into t minus 2. T times t, t times t, t squared. T times negative 2, negative 2t. Negative 2 times t, negative 2t. Negative 2 times negative 2, positive 4. Which is equal to 5 into t squared minus 4t plus 4. Which when we expand is 5t squared minus 20t plus 20. And this are equal to each other. Also notice that in this case, all parts of this function are in the form y is equal to a t raised to the power n. Therefore, the general rule for differentiating a function, that is dy over dt, in this case, because we are differentiating y with respect to t, is given as t raised to the power n minus 1, which for our problem, dy over dt would be, for the first part, 5 times 2t raised to the power 2 minus 1 minus For the second part, 20 times 1, because in this case, t is raised to the power 1. T raised to the power 1 minus 1. Plus, we know that when 20, which is a constant, is differentiated, it gives 0. So that's plus 0, which in all is equal to 5 times 2 is 10. T raised to the power 2 minus 1 is 1. 1 minus 20 times 1 is 20. T raised to the power 1 minus 1 is 0, which is equal to 10t minus 20, because t raised to the power 0 is simply 1. And that's the final answer to this problem. Remember to solve as many more questions on this rule as possible. And if you found this video helpful, kindly give it a like. And if you are yet to, subscribe to this channel for more helpful content. See you in the next videos.